This is Sunil Rafiq from Lahore Grammar, Johor. Today my lesson is going to be about the binomial expansion. First of all, I will just give you a little explanation what is a binomial. Such terms 2 plus x plus y, x squared plus 1, they are known as binomials. Some student asked me that can't this be a binomial? No, because this will become a constant 5. So binomial is where two variables are added or just a variable and a constant are added together. Now as the word expansion, you already know that expansion is something, a very famous expansion I'm going to share with you guys. You already know that x plus y square is x square plus 2xy plus y square. Here I would like to draw your attention to the coefficients, and they are, look at this. Here we have the coefficient 1 and 1. So I will just circle them. This one is not working. Okay. So I will just circle them like this. They are the binomial coefficients. What if I have to expand x plus y cube? In case you do not know this expansion, I will tell you that this expansion is x cube plus 3 x square y plus 3 xy square and plus y cube. So this is also a binomial expansion. I will again let you know what are the coefficients over here. Look at this. 1, 3, 3, 1. So that sounds pretty simple, but what if you need to expand somewhere like 7? Now what will you do? This expansion will be a massive. There are ways like you can write x plus y, x plus y, x plus y, x plus y, x plus y. How many are 1, 2, 3, 4, 5, 6 and 7? Do you think it is possible to multiply 2 and 3 and 4? This is quite a big work. You need a whole quite a lot of time for this. There is a special technique known as the Pascal triangle technique. The credit goes to Mr. Pascal, a very famous mathematician in Greece. Observe this triangle. I'll just make a 1, 1, 1. Observe. 1, 1. The diagonally 1 goes. 1 plus 1, 2. 1 plus 2, 3, 3. 4, 6, 4. 1, 5, 10, 10, 5, 1. I'm adding the intermediate term 6 plus 4, 10. 6 plus 4, 10. So on. This triangle is known as the Pascal triangle. It can go all the ways. Now just don't bother with this 1. Observe these. These are the coefficients of x plus y whole square. You can see 1, 2, 1. 1, 2, 1. These are the coefficients of x plus y cube. Look, 1, 3, 3, 1. 1, 3, 3, 1. And so on. If you expand 4 or you expand 5, you can get the coefficients of a binomial theorem by this. But as again, what if you get something like x plus y 15? Even then the binomial, the Pascal triangle will be very large and it will be a very hectic work to go all the way down to 15. And if it's 23, then what? So we have to devise such a technique using the modern theory of mathematics that is known as a combination. You must all know that NCR, this is known as a combination. Combination is defined as the way in which we select some particular object without the order of the selection. I'll be sharing another lesson in a few days about permutation and combination. Then I'll give a mighty explanation regarding combination. So this is n factorial over n minus r factorial into r factorial. We are not concerned with this right now. I just need you guys to focus on this. This is going to be a very essential tool. If I show you in a triangle, in a scientific calculator, focus on this key. Look at this. There is a shift button and this NCR you can check. I'll tell you how to find combinations. But for right now, we will again observe the Pascal triangle in a different way. Observe. This is 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. And side by side, observe another triangle of combinations. Just forget about 1. This is 1C0 and 1C1. Then we have 2C0, 2C1, 2C2. Then we have 3C0, 3C1, 3C2, 3C3. Then so on. If you go like this, you will observe that, look at this. 3C0, if I do 3C0 in my calculator, I will press 3, shift, combination and 0. 3C0 is 1. Then 3C1 is 3. Then 3C2 is 3. A combination like NCR, this R cannot exceed by N. This can never be N plus 1. What I mean to say is 7C10. This is not possible. This is wrong. You can always go from 0 up to 7. That is the last combination you can make. Out of 7 things, you cannot exceed a combination. So, these will 3C0 is 1, 3C1 is 3, 3C2 is 3, 3C3 is 1. And similarly, you can see that these combinations are very essential when you are applying. So now I will generalize my rule that how to find the coefficients where the terms, the n is very large, mean the number of objects. So if we go all the way up to